But if you're saying these are diverse coronaviruses and you can't vaccinate against them, there are no antivirals, what do we do?
Well, so I think that coronaviruses are pretty good. I mean, you're a virologist, you know all this stuff, but you can manipulate them in the lab pretty easily. It's just spike protein drives a lot of what happens with the coronavirus, zoonotic risk. So you can get the sequence, you can build the protein, and we work with Ralph Barrick at UNC to do this. Insert it into a backbone of another virus, and do some work in the lab. So you can get more predictive when you find a sequence. You've got this diversity. Now, the logical progression for vaccines is if you're going to develop a vaccine for SARS, people are going to use pandemic SARS as
sure.
But let's try and insert some of these other related and get a better vaccine.
And I guess also knowledge of what's there. If you see something emerging, it give it a head start on making a vaccine or a therapeutic.
That's true, and better knowledge of where they are as well, so that you can put your money into the clinics that matter. And that's one of the big things that we've been trying to push. There's a lot of the word predict, or the word anticipating, forecasting pandemics. It doesn't mean you can stop them. That's the problem. There's So what we're trying to do is say, on a global scale, if we can show where they're most likely to come from, the species they're most likely to originate in, the people most likely to get affected, a global actor like WHO or a national government can better allocate resources to the highest risk. It's pretty